Welcome everyone. For today's prep, we're going to look at an example for how to computationally find the intervals of increase-decrease for a function. So we started looking at this in class, and we know we're going to be using the first derivative. So we've seen this before. We want to know where the first derivative is positive. That'll tell us where our function is increasing. And to figure out where our function is decreasing, we want to know where the first derivative is negative. So if we know where our first derivative is either positive or negative, we'll know where the original function is either increasing or decreasing. And the way we find where this happens, we want to find the sign of f prime here. And the only way it can change signs is at these special places where either the derivative is 0 or the derivative does not exist. So these are the only places where f prime can switch signs. So if you go from positive to negative, you either go through the horizontal axis or you jump across the horizontal axis. And these values are called critical numbers for the original function, with one extra condition here, that they're in the domain of the original function. So our strategy is going to be to calculate f prime, figure out where the derivative is 0, figure out where the derivative does not exist, and then we're going to do a sign chart for f prime, and then ultimately determine the sign of f prime on each interval. So let's jump down to example 2. So we have this function here, f of x equal to 1/3 x cubed minus 2x squared plus 3x plus 1. And we're going to find the intervals of increase and the intervals of decrease for this function. And we're going to use this technique. So our first step is to calculate the derivative. So we want to get f prime. Well, we've learned all these derivative rules now, so let's put them to use. So differentiate the first term, we get x squared. Differentiate the second term, we get minus 4x. And then differentiate the third term, we get 3. And then derivative of the constant that's all by itself is just 0. So we have our first derivative. And usually it's a good idea to just try to factor this right away, because we're going to be doing things with this. So let's try to factor this. And in this case, it does factor nicely. So we get x minus 3 times x minus 1. So it factors. And check, negative 3 times negative 1 gives you positive 3. And then negative 3 plus negative 1 gives you the negative 4 there. All right, so that's the first step. Calculate the derivative, and then see if you can factor it right away. Then the next step is to look for the critical numbers. So this is where either the derivative is 0 or the derivative is undefined. So we want to think about, where is the derivative 0 or where is the derivative undefined? So the derivative can be usually what we're going to see when the derivative is undefined or does not exist. We're going to see some division by 0. Usually that's what happens. There's other cases, but that's the most common one we're going to see. So you want to look at this derivative and see if you have division by 0. There's no division anywhere. This is just a regular polynomial. So in this case, none. Really, though, you're looking for division by 0. Okay. So let's go to the more common situation. We want to know where the derivative is equal to 0. Well, let's set our derivative, and let's use the factored version. So we're going to set our factored version equal to 0. And why it helps to have it factored is, well, then we can set each individual factor equal to 0. So we get x minus 3 equal to 0, and we get x minus 1 equal to 0. And then if we solve those, well, we can do it. So we get x equal to 3, and we get x equal to 1. Okay. And just a quick check, these two numbers that we found are actually in the domain of the original function. So we could plug 3 in and we don't get any division by 0 back into the original function there. And when we plug 1 in, we don't get any division by 0. So these are both critical numbers. Okay. So what are we going to do with these? Well, these are the places where f prime can switch signs. So now we're going to set up our sign chart for f prime. Okay, so let's draw our x-axis. This is the x-axis. And let's take these two values that we found. So x equals 1, x equals 3. Let's plot them on here. So just make sure we get the right order. So we got x equals 1, x equals 3. And what these two values do is they slice up our x-axis into 3 separate sections. So let's write out what the intervals are for those sections. So this left interval will be from -infinity to 1. The middle section here will be from 1 to 3. And then finally 3 to infinity. And our goal here is to figure out, ultimately, what is the sign of f prime on each of these intervals. And that'll tell us what f is doing. So to help us with this, we want to know, on this first interval, is f prime positive or is it negative? And that'll tell us, is f increasing or is it decreasing? So to help us with this, what we can do is we can use the factored version of our derivative. And we can take every single one of these factors here. And we're going to figure out the sign of each one of those individual factors. So we have the x minus 3 factor and then the x minus 1 factor. And to help us out, it's sometimes helpful to use test numbers for each of the intervals. And what we're going to do is we're going to just pick a test number, some number that's inside this interval, and we're going to plug it into each of these factors and see if we get a positive or negative result. So let's start with our first interval here. We want pick a number that's less than 1. So 0 is always good. So let's pick t equals 0, our test number 0. And we're going to plug this into the first factor, x minus 3. And when we do that, we get 0 minus 3, so we get a negative result. And if we plug that into the second factor, we get 0 minus 1, so negative 1. So it's negative there. And what this means then is, by the factoring of f prime, on that interval, we have a negative number times a negative number. So this is a double negative, which means f prime is positive. And that tells us the original function f is increasing on that interval. All right, so then we just kind of repeat this for all of the different intervals. So we go to the next interval, something we want to pick a test number between 1 and 3, so 2 would work. And then we plug 2 into the first factor. We get 2 minus 3, which is negative 1. We don't really care about the number, we just care about the sign. So in this case, negative. Then we plug 2 into the other factor, so we get 2 minus 1, which is positive 1. So positive. And here we have a negative number times a positive number. So just a single negative, which means the result is going to be negative. So that means f prime is negative on this interval. And if f prime is negative, that means our original function is decreasing. And then finally, for the last interval, pick another test number. And in this case, maybe just something bigger than 3, so 4 would work. And we just plug it in. So plug it in here. We get 4 minus 3 is positive 1. Go to the other one. Plug it in there. 4 minus 1 is positive 3. So positive. And then a positive times a positive is positive. And when f prime is positive, that means our original function is increasing. So step 3 and 4, kind of write out the sign chart and then fill it in. All right, so we've done it. let's get our answer here. So we know f is increasing on the interval minus infinity to 1 and on the interval 3 to infinity. And then f is decreasing on that middle interval, 1 to 3. So this is going to be it. This is our strategy for how to figure out where a function is increasing or decreasing. So the first step is calculate the derivative, and if you can, factor it. Then you look for the critical numbers, so where either the derivative is 0 or does not exist. And then these numbers that you find are going to be what you plot on the kind of initially on the sign chart, and they split your x-axis up into the intervals, and then you figure out the sign of each of the factors there to get the sign of f prime. All right, so we'll practice more of this in class, but a nice one here to get us started. So we'll see you then. Bye-bye.